Hi there. So I'm going to start chapter 3 now. Chapter 3 is on quadratic functions. However, before we actually get into the meat of the section, at the end of the chapter, there is something called a skills refresher, and that's what I would like to go through today. Okay, so this is a skills refresher. I'm going to call it section 3.0. But we're going to use this as a skills refresher. Now, one other quick thing that I would like to say is that I'm assuming that you guys have done these things before in the past. I'm just trying to refresh you guys, okay? One of the things we're going to be talking about is factoring, and then the other thing we're going to be talking about is called completing the square. Now, the important thing before we actually start factoring is to be sure that you know how to use the distributive property. Okay, so what's an example? Well, using the distributive property, suppose I have -4 times the quantity y plus 6. Well, what this says is distribute your 4 throughout your parentheses. So I claim we get -4y minus 24. Okay? And we could do another one. Suppose I have, say, 3z times the quantity 2x minus 9z. This might not be very pretty, but we can do this. Okay? So, again, you just distribute it throughout your parentheses. So, if I take 3z times 2x, I claim I get 6xz. Now, yes, you could put zx. I just like to put things in alphabetical order if I can. Minus, well, 3 times 9 is 27, and z times z is z squared. Okay, now let's do another one. What if I have x times the quantity 3x minus 8 plus 2 times the quantity 3x minus 8. All right. Now, instead of distributing, what I want us to do is essentially combine like terms and factor. Okay? I mean, one thing we could do is we could say, well, this is 3x squared minus 8x plus 6x minus 16. Okay, and then combine like terms. Okay, but what if, what if I wanted to say, instead of using the distributive property, what if we wanted to actually factor this guy? Okay, this is kind of jumping a little bit ahead, but I think it's really important. Okay, notice one of the things that you do when you factor is you look for common terms. These guys both have a 3x minus 8 in common. So I claim we can pull out 3x minus 8. Okay, I'm doing kind of the anti-distributive property. If I pull this 3x minus 8 out of the first term, well, he's gone, and x is left. And if I pull the 3x minus 8 out of my second term, he's gone, and I'm just left with an x plus 2. I know that's kind of funky, but it's really important to be able to look for things like that. Okay, now what I would like to do is practice with one foiling guy. Let's do this. Suppose I want you to multiply this out. Okay, this is where we use that acronym FOIL, first, outside, inside, last. Okay, if we multiply our first terms, we get 10, that did not show up very well, 10x squared. Our outside terms, we get minus 15x. Our inside terms, minus 2x. And then our last terms, plus 3. So then if we combine like terms, we get 10x squared minus 17x plus 3. Okay. Now, what I would like to do is talk about how, in general, when you need to factor something, what are the steps that you should go through in order to do such. Okay? So, when you factor, the first thing that you should do, no matter what you're factoring, is pull out any common factors. For example, what if I have 4x minus 6 and I want to factor that? Okay, well, remember, terms are things that are separated by plus and minus signs. What do both 4 and 6 have in common? I claim 2 goes into each of them. Well, if I divide my first term by 2, I claim I'm left with a 2x. And if I divide my second term by 2, I claim I have a minus 3. Now the beautiful thing about this is you can just check your answer by using the distributive property, 4x minus 6. All right, what if we want to do this guy? Okay, how about 3y plus 3? What do these guys have in common? Well, I claim there's a 3 in each term. If I divide my first term by 3, I have a y left. Now, I will grant you that if I pull the 3 out, it looks like on first sight, oh, there's nothing there. But remember, you're dividing by 3, and 3 divided by 3 is 1. Okay, what if I have something like this? 3u to the 4th minus 4u cubed. Now, in terms of our numbers, there's nothing in common. However, here I have 4 u's, and here I only have 3 u's. So, what can we pull out? I claim you only can pull out the smaller amount. So what do I have left in my first term? Well, I still have this 3. I started with 4 u's. I took 3 out, so I have 1 left. And in this next term, notice I took out all my u's, but I still do have that minus 4. Okay, so no matter what you're doing when you factor, the first thing you got to do is pull out any common factors. The next thing that you should do is as follows. You should note that if what you're factoring has 2 terms, you should be on the lookout for what we call the difference of 2 squares. And this is a formula that you should have seen before. Okay? Essentially, what this says is if your first term is squared and you're subtracting off another term that's squared. That's why it's called difference, because we're subtracting. Okay? I claim what you do is you take the first guy that's being squared, add it to the second guy that's being squared, times the first guy that's being squared minus the second guy that's being squared. If you don't believe me that it factors this way, well, we can verify that, right? We can FOIL this out, and then we should get what we have over here. Let's do that. X times x is x squared. Our outside terms give us minus xy. The inside terms give us plus xy. And the last terms give us minus y squared. What happens to these 2 terms? They cancel each other out, And lo and behold, we've got it. So, for example, what if I have x squared minus 9? Well, would you agree that that's x squared minus 3 squared? So to factor that, you take the first thing that's being squared and add it to the second thing that's being squared, and then the first thing that's being squared minus the second thing that's being squared. And again, the beauty of this stuff is you can always check your answers. Okay. Next. Oh, let me just do one more example while I'm thinking of it. Why don't we do, oh, this is cute, 9x squared minus 9. Okay, suppose I want us to factor that. Well, what's the first thing you should do whenever you factor something? Pull out any common factors. So let's look right here. What's in common in both of my terms? We have a 9. So if I pull a 9 out of my first term, I'm left with an x squared. If I pull a 9 out of my second term, I'm left with minus 1. But I claim I'm not finished. Why? Because I claim this is actually the difference of two squares. In other words, we could say, oh, that's 9, and then this is take the first thing that's being squared plus the second thing that's being squared, and then you take it times x minus 1. Isn't that cute? All right. So, the third step with factoring, you'll see why I said 4 in a second, is if there are 4 terms, you want to factor by grouping. And I claim that's like doing step 1 2 times. Okay, let me show you an example. X cubed minus 2x squared plus 3x minus 6. Okay, now what's the first thing that we should do whenever we approach a factoring question? We should pull out any common factors. But I claim we have nothing we can pull out of here. Okay, so there aren't 2 terms, nothing to do there. But there are 4 terms. So how do you factor by grouping? Essentially what you do is you group your first 2 terms and your second 2 terms. And then you pull out any common factors. Okay, what do these guys have in common? I claim we can pull out an x squared. If I do, I'm left with an x minus 2. In my second group, I claim I can pull out a 3. If I do, I'm left with an x minus 2. Now this should ring back to an example I did just a moment ago. Notice now we can still pull out a common factor because both of these terms have that x minus 2. If I pull out the x minus 2 from my first term, I'm left with this x squared. And if I pull the x minus 2 out of my second term, I'm left with plus 3. Isn't that cool? Okay, let's do another one. All right, what if now I have x cubed plus 4x squared minus 3x minus 12? All right, again, group our terms. I can pull an x squared out of my first group. I claim I'm left with x plus 4. And over here, I want to look ahead and say, gosh, I want to pull something out so that I can be left with a positive x and a positive 4. Notice both of these are negative. So I'm going to pull out a negative 3. If I take this negative 3x divided by a negative 3, I have a positive x. Negative 12 over negative 3 is a positive 4. Again, I've got this term in common. I pull out my x plus 4. If I do that, I'm left with an x squared in my first term and a minus 3 in my second term. Am I done? Actually, I am, because notice 3 is not a perfect square. All right, one more example for now. What if I have x cubed minus x squared minus 9x plus 9? All right, again, let's factor by grouping. I can pull an x squared out of my first term. Well, I'm left with an x minus 1. Now notice my first term here is negative, my second one is positive, but I'd like to pull something out, so I'm left with a positive x. So what I'm going to do is pull out a negative 9. If I pull out a negative 9, I'm left with a positive x, and then notice 9 over negative 9 is a negative 1. Okay? Next, I can pull out my x minus 1. If I do that, I'm left with an x squared in my first term and a negative 9 in my second term. I claim this time I'm not done. Why? Because 9 is a perfect square. Isn't this the same as x squared minus 3 squared? So, don't forget to rewrite this guy. We have an x minus 1, and then we factor that to be x plus 3, x minus 3. I like that. Okay. Finally, step 4 is if there are 3 terms. Okay, the first thing that we're going to be dealing with is if we have a coefficient of 1 in front of our x squared term, because that's a lot easier of a situation. For example, what if we want to factor x squared plus 5x plus 6? Okay, notice there's a coefficient of 1 in front of my squared term. When you approach these guys, well, you're kind of anti-foiling, if you will. Okay? My first terms I know are each going to be an x. X times x gives me x squared. Now, the way I want to look at this is I want to find 2 numbers whose product is the last number and whose sum is the middle number. Okay? Well, if I want to multiply up to a positive and add up to a positive, I claim both of them have to be positive. So what 2 numbers multiply up to 6 and add up to 5? 3 and 2. Okay? Now let's do this guy. I'm going to keep using these numbers or something very close. What if now I wanted to do x squared plus 5x minus 6? Well, again, I will have x and x here, but now I want to multiply up to a negative number. The only way you can multiply up to a negative number is if one of them is positive and one of them is negative. Since my sum is positive, I know that my bigger number has to be positive. So now 3 and 2 won't work, but I claim positive 6 and negative 1 will work. Okay? On the other hand, what if I have x squared minus 5x minus 6? Again, they're going to start out with x's, and again, one is positive and one is negative because that's the only way we can multiply up to a negative number. But now what I want is them to add up to a -5. Well, since the sum is negative, I know my larger number is negative, and I claim -6 and +1 work. Okay, 2 more along this line. Let's do x squared minus x minus 6. Okay, well, I know we've got x's at the start. I know that they have to multiply up to a negative number, so I know one is positive and one is negative. But now notice they need to add to a -1. Again, since the sum is negative, the larger one is negative, and in this case, a +2 and a -3 work. All right. Now, what if the number in front of your x squared is not a 1? Okay? Then these can be a little more of a pain, but they're certainly doable. So what if I have something like this? Suppose I have this guy, 6x squared plus 6x, 6x squared plus 2. Oh, excuse me, plus 7x. I was going to say, that's not going to work. Minus 3. Okay? Now, what I want to present to you are all the different issues we have going on, because this isn't a 1 in front of here. Okay? We can do this by trial and error. Do you agree that the only way I can multiply my first terms to get a 6x squared is if I have a 6x and an x? Or a 2x and a 3x? Okay? So already we're starting to introduce a lot of possibilities. Now, there aren't a whole heck of a lot here because my last number is a prime number. It's a 3, and the only way you can multiply up and get 3 is if you have a 1 and a 3. But notice one is positive, one is negative. So what I'm going to do is I'm going to write some general steps on how you would solve this. Okay? So when you don't have a 1 in front of your x squared term, what I would recommend you do is you need to find 2 numbers whose product is the first number times the last number, and whose sum is the middle number. Okay? In other words, we want to find 2 numbers whose product is -18 and whose sum is 7. Now, if it helps to write out all the things that multiply up to 18, go for it. Okay? Notice the product is a negative number and the sum is a positive number, so we know one is positive and one is negative. But since my sum is positive, we know that the bigger number is positive. I think you'll grant me that 9 and -2 work. Okay? So we found those numbers. By the way, if you can't find those numbers, this isn't factorable. Step 2. What we do then is rewrite the middle term using those numbers. Why? Because step 3 will be factored by grouping. Let me show you how this works. Okay. So we found these numbers. Now step 2 says rewrite the middle term using them. In other words, we have 6x squared, but in place of 7x, I'm going to say, well, that's a 9x minus 2x. Okay, I haven't changed the value of anything. All I did is rewrite the middle term, but I claim if you combine like terms, what we have is equivalent to what we have above. Now notice, what do we have? We've got something with 4 terms. We can factor him by grouping. What can we pull out of our first terms? I claim we can pull out a 3x. And if I do that, well, I'm left with a 2x plus 3. Now I ask myself, is there anything I can pull out of my second group? Offhandedly, no. Okay, 2 and 3 don't have anybody in common. But I do claim I can pull out a -1, and then I'm left with a positive 2x and a positive 3. And now these guys have a 2x plus 3 in common. I can pull them out, and I'm left with a 3x minus 1. All right, let's do one more example there, and then we're going to keep playing, don't you worry. But let me pick a good example. So now what if I had 6x squared plus x minus 12? Now again, if you want to do these by trial and error, just playing around with different possibilities, you're more than welcome to. But notice, we could either start with a 2x, 3x, or an x and a 6x. But there's a lot of different ways we can multiply up to a 12. So let's use the technique we've established. We want to find two numbers whose product is our first number times our last number, which is -72. And whose sum is 1. Well, play around with all the factors of 72, and I claim a +9 and a -8 are going to give it to us. These guys multiply up to -72, and they add up to a +1. So, next step, rewrite our middle term using those numbers. So we have 6x squared plus 9x minus 8x minus 12. And now we'll factor by grouping. I can pull a 3x out of my first group, and I think we've seen this before. Look right over there. We're left with the 2x plus 3. Okay, what can I pull out of my second group? Well, I can pull out a -4, and I'm left with a 2x plus 3. I pull out my 2x plus 3, and I'm left with a 3x in my first term and a -4 in my second term. So I hope this helped in terms of factoring. Now, one of the things that we tend to do, and you'll see why soon enough once we get into the meat of chapter 3, is we want to solve various quadratics. And one way to solve them is by factoring. But the key thing to remember is we have our property of 0. What that says is if you multiply two things together and get 0, so if A times B is equal to 0, then what we can conclude is either A is equal to 0 or B is equal to 0 or both, right? The only way you can multiply things together to get 0 is if one or both are equal to 0, okay? So, for example, what if I wanted us to solve x cubed minus 2x squared minus 3x equal to 0? And I'm going to tell you we're going to do this by factoring. What's the first thing you do whenever you factor? You pull out what's in common. What can I pull out? I can pull out an x. Okay, if I pull one x out of here, I still have 2 left. If I pull an x out of my second term, I'm left with minus 2x and then minus 3. Next step, let's factor this guy. You still have to write this first x. He still carries through. Notice these are both going to start with an x, and since I'm multiplying up to a negative number, I certainly know that one is positive and one is negative. So, this is nice. We don't have a lot of choice. What numbers multiply up to 3? 1 and 3. But since the sum is negative, I know my larger one is negative. All right then, we factored it. Now notice, yes, we have 3 terms here, but we can extend this. The only way you can multiply things together to get 0 is if the first one is 0, the second one is 0, or the third one is 0. In other words, if x is equal to 0, if x is equal to negative 1, or if x is equal to 3. Isn't that fun? Okay, one more. Okay. What if I have this? This is just a factor. X squared e to the negative 3x plus 2x e to the negative 3x. Okay? Don't get messed up by this e business. Okay? We will be talking about our exponential functions with base e later on in this class. But right now, the way you want to approach this is you want to pull out whatever is in common. Okay? Now, what do we have? We have an x squared here and an x here. So we can pull out one of those x's. And don't I have an e to the negative 3x in both terms? If I pull that out, notice this is gone. I had 2 x's, I pulled 1 out, so I've got 1 x left. And over here, I pulled all this out, and I'm just left with plus 2. Okay? So, if you see a homework problem with these e's right now, don't let that freak you out. Okay? You will understand the meaning of it soon enough. But I just wanted to give you a heads up. All right, so that's factoring. Now what we need to do is talk about completing the square. Okay, we like perfect squares. 1, 4, 9, 16, 25, etc. Because they're actually equal to some quantity squared. But we can also look at our quadratics as perfect squares. For example, x plus 2 quantity squared. If you multiply that out, trust me, that's equal to x squared plus 4x plus 4. Okay? So we say, oh, this can be written as some quantity squared. It's x plus 2 times x plus 2, aka x plus 2 squared. I claim another perfect squared is something like, how about x squared minus 6x plus 9? Okay? I claim, and you can verify, that that's equal to x minus 3 quantity squared. If you multiply it out, x minus 3 times x minus 3, trust me, you're going to get back to where we're going. Okay? So, one of the things that we like to do is be able to write things in terms of perfect squares. Okay? So, how do we do that? Well, I'm going to write out some things in general, and then what we're going to do is apply it into a bunch of different specific examples. Okay? The rules for completing the square is, first off, you need a coefficient of 1 in front of your squared term. Okay? If need be, you can factor him out. 2, and again, these steps are going to seem funky. Bear with me. What you do is you take half of the middle term and you write it to the side. Okay? Step 3, you square that number, and then what you do is you add, I'm going to say, and compensate. That's going to seem strange. It's okay. The key in life with anything is balance, and that carries over in mathematics. Okay? So, let's go through and start these. We're going to build slowly, and you'll see how this is going to relate in a little bit in this section. So, for example, if we want to complete the square for this guy, x squared plus 8x, okay? I know every part of you wants to factor out an x, and I get it, but that's not what we're doing here. We want to complete the square here. Well, notice we have a coefficient of 1 in front of our squared term. Life is good. Now, what we want to do, normally there's a third term, which is why I call this the middle term. Take half of this number. We get a 4. Okay? Now what we have to do is square it. Okay? And if you square 4, I claim you get 16. Okay? Now, why would we want to do this? This is just a prelude example. Because I claim you can then write it as a perfect square. What number should go here? Whatever you got when you took half of that middle number. Okay? So, how would we end up using this? Well, let me show you an example here. What if we have this? X squared plus 4x minus 5. Okay? Now we actually have a middle term. Excuse me. And we want to complete the square here. Okay? Now, our goal in the end is to write it in this form. Some number like this. You'll see why. Just hold on. Okay? So, what we do is we take, notice you have a coefficient of 1 here. You take half your middle term. Half of 4 is 2. And what do we do with that? We square it. So, x squared plus 4x plus 4. Now, I still have this minus 5. Okay? I've completed my square here. I'm going to get to that compensate or balance comment that I made over there. Okay? Can you just add 4 onto an equation and think that you've got the same equation? Absolutely not. Okay? So I need to balance it. If I add 4 here, in order to keep the same thing, I've got to subtract 4 out there. Okay? Now, what we'll do is write this as a perfect square. What number goes here? Well, that 2 that we wrote on the side. Okay? All right, let's do this one. What if I have oh, this is a good one. Negative 4x squared plus 8x minus 3. Notice I do not have a coefficient of 1 in front of my squared term. Okay? When you don't, what you're going to do is the following. Factor it out of the first two terms only. Okay? So, I'm going to pull that negative 4 out, and I'm left then with x squared minus 2x. Notice I only pulled him out of my first two terms. Okay? Again, you can distribute and verify that you get the exact same thing. We're not changing our equation at all. Okay, now what we're going to do is complete the square. Things are going to get a little funnier here though. Ready? Okay, I'm going to complete the square with this term. Well, how do you do it? You take half of this number. What's half of negative 2? I claim negative 1. I always write them off to the side. When I square that negative 1, I claim I get a plus 1. Okay? I still have that minus 3, but notice I've just added an extra term here. Okay? That's where this balance comes in. Okay? And yeah, in parentheses, I added a 1, but notice there's that negative 4 out there. So haven't I essentially subtracted 4 from my equation if I was going to distribute that? And if I subtract 4, in order to keep balance, I have to add it on at the end. So now I want to rewrite this as something squared. Again, what number goes here? What we got when we took half that middle term, or negative 1. And that's what we have. Okay? Let's do another one of these. What if I want to do this one? Let's actually change it slightly. What if now instead of solving by factoring, we want to solve by completing the square? What if I have x squared, let's do this, 3x squared minus 6x minus 7. All right, how would we go through and solve that? Let's actually make this a little nicer for ourselves and start out with an x squared. First off, why did I change that? Because I want to point something out. Couldn't we factor this? Yeah. Okay, as an aside, I know, oh sweet, that's x minus 7x plus 1. Right? So, got the product of two things equal to 0. Either the first one is 0 or the second one is 0. Doesn't that give us x equals 7 or x equals negative 1? Okay, let's do this by completing the square though. Okay, this is cool. Ready? If you're going to solve something by completing the square, the first thing you do is move your constant to the other side. So we have x squared minus 6x equals 7. Okay? Next, complete the square. How do you do it? You take half of this middle term. Half of negative 6 is negative 3. What do you do with that negative 3? You square them. Now, instead of adding, subtracting to balance, now I have an equation. So if I'm going to add a number to one side of my equation, don't I add it to the other side? Okay. Next step, I think you'll grant me 9 and 7 is 16. What number goes here? The number we wrote off to the side when we take half of that middle term. All right, how would we solve this? Well, I'm certain you've seen this before at some point in your life. You use the square root method. You got some quantity squared, so we can take the square root of both sides. On our left side, we get an x minus 3, and we're in luck. On our right side, we can get plus or minus 4. Again, you don't just consider the principal square root, you consider both your positive and your negative values. So, in order to get x all alone, I can add 3 to both sides. And don't I have x then is 3 plus or minus 4? In other words, one solution is 3 plus 4, aka 7, and the other solution is 3 minus 4, aka negative 1. Notice you get the same thing either way. That is so cool. All right, now again, I'm just going through a few examples here because you guys have probably seen this at some point in your life. At least that's my hope. Now, perhaps we should do one more example, and then I'm going to show you something so beautiful. I'm really excited about it. Okay? Before I show you my such a beautiful thing, let's do one more example of completing the square and solving. What if I have this? How about y equals, oh no. Let's do this. We're going to solve. So how about we have 2x squared plus 4x minus 5 equal to 0. Okay? If I asked you to factor this, you wouldn't be able to. Okay? He's not a factorable one. So, what's my first step? Well, notice I've got a coefficient of a 2 in front of my squared term. Okay? So, when you're solving, essentially, what I would recommend you do is just divide everybody by that coefficient. Okay? If I do that, I have an x squared plus 2x minus 5 halves equals 0. Are we kind of bummed that we got a fraction? Yeah, I am, but it's okay. All right, so now I have a coefficient of 1 in front of my squared term. Okay, so I do want to point out that when you're just, when you're not solving something equal to 0, if I just had y equals this, then I would just factor the 2 out of my first terms and go through and complete the square. But when you're actually solving, you need to divide all the terms by him. Okay? It's an important distinction to make. Okay, my next step is move my constant to the other side. I added him. Now what I'm going to do is complete the square. I take half of this middle number, half of a positive 2 is a positive 1. I square him and I get 1. Now, fair is fair. If I add it to one side, I'm going to add him to the other side. I can write this side as a perfect square. What number goes here? What I got when I took half of my middle term. And 5 halves plus essentially 2 halves is 7 halves. Now, in order to solve this, what I'm going to do is take the square root of both sides. I didn't say it's pretty. All right, the square root of something squared is itself. And here I'm going to get positive and negative the square root of 7 halves. Okay, so if we were leaving this as an exact answer, Well, we'd get x alone by subtracting 1. So we could say -1 plus or minus the square root of 7/2. And for our purposes right now, I'm just going to leave it like this. Again, one solution is -1 plus the square root of 7/2, and the other solution is -1 minus the square root of 7/2. Okay? Now I'm going to show you something that's really cute, cool, beautiful, all those words combined. Okay? I would not ask you to do this on your own. Not that it's dangerous for your health, but this is so cool. Ready? I want to complete the square for this. Okay? Now, my only rule, my only stipulation is a can't be equal to 0. Okay? You might ask, why would I want to solve something like this by completing the square? Hold on a second and you will see. Okay? So, remember, if we're actually solving this equal to 0, in order to complete the square, the way we get a coefficient of 1 in front of our first term is we divide everybody by that. Yes, this is kind of yucky looking. It's okay, because I'm the one doing it anyway. So, if I divide through by a, I have x squared plus b over ax plus c over a equal to 0. Okay? Again, a is not 0, so it was totally legal to divide by him. Our next step, move our constant to the other side. I have x squared plus b over ax equals -c over a. All right, ready? Next, we want to complete the square. How do you complete the square? You take half of your middle term. Remember, in mathematics, the word of means multiply. So if I'm taking 1/2 of b over a, I'm multiplying them. When you multiply fractions, you multiply your numerators and you multiply your denominators. So when I take half of my middle term, I got b over 2a. The thing is, next step when you're completing the square is you want to square him. Okay, well, what do you get when you square b over 2a? Well, you get b squared. 2 squared is 4, a squared. So I'm going to add on b squared over 4a squared to both sides. b squared over 4a squared, and then we have that. I know this looks nasty, but just hold on. You're going to have a peak experience here, seriously. Okay, so I claim even though our left side looks terrible, it's actually the easier side to deal with because he's a perfect square. Again, what number goes here? Well, what we got when we took half of our middle term, b over 2a. Now on our right side, we can't combine those yet. We need a common denominator, okay? I have a 4a squared here and an a here, so my common denominator I claim would be 4a squared. How do you get it? Well, don't we need another 4a down here? And again, fractions are like kids. Whatever you do to your denominator, you got to do to your numerator. So I claim we have b squared over 4a squared minus 4ac over 4a squared. Well, we got a common denominator, so don't we have b squared minus 4ac in our numerator? Our next step is to take the square root of both sides. The square root of some quantity squared is itself. We get plus or minus. Well, we can break this big square root up to be the square root of our numerator. over the square root of our denominator. But let me ask you this. What's the square root of 4a squared? Well, the square root of 4 is 2, and the square root of a squared is a. So, by moving this over, notice I have a common denominator of 2a. This would give me a negative b plus or minus that square root. And look at what we have. When you're solving a general quadratic set equal to 0, here's our solution. I bet you've seen this before. This is our quadratic formula. That is so cool. So if you've ever wondered where your quadratic formula came from, it came precisely from completing the square. Okay, again, that's not something I'm going to ask you to do on your own, but I think it's cool to see where a formula actually comes from because it actually gives meaning to it. Okay, so just to summarize, and then I will solve one example using my quadratic formula, and then we'll call this lesson done, is this. Factoring is really fun. Okay, the thing is it works rarely. So the bummer with factoring is it doesn't always work. Okay, you can also solve these guys by completing the square or by using your quadratic formula. These two guys always work. Okay? Now, honestly, if I had my druthers and I wanted to solve a quadratic, I would use my quadratic formula over completing the square. You'll see the utility of completing the square in chapter 3 and how that's relevant. However, if I'm actually solving a quadratic and I notice that it can't be factored, my own personal thing is always just to use my quadratic formula. So let's do one example using our quadratic formula, and that's that. So 2x squared plus 6x minus 3 equal to 0. Your quadratic formula, I'll rewrite it here, says when you have this, the solution is negative b plus or minus the square root of b squared minus 4ac all over 2a. A is the number in front of x squared, b is the number in front of x, and c is your constant term. Okay, let's do this. So first thing, when you're just starting this out, it might be useful to identify what's a, b, and c. A is 2, b is 6, and c is negative 3. Let's plug it in our formula. Negative b. Well, if b is a positive 6, negative b is negative 6. Plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Okay, let's see what we get. Negative 6 plus or minus. Well, 6 squared is 36. 4 times 2 is 8. Times 3 is 24. But notice minus a negative is plus a positive. And that whole thing is over 4. All right. So you get negative 6 plus or minus. Well, what's 36 plus 24? That's 60 over 4. Now, this can be simplified. Remember, the way you can simplify it is to simplify a square root. Yes, you can get a decimal approximation, but I like to leave things in exact form. I claim, well, can we simplify 60? Well, how would we do that? What you would do essentially is say, how can we break up the number 60 so at least we can take the square root of part of it? And I claim 60 is 4 times 15. So you get negative 6 plus or minus. The square root of 4 is 2, root 15 over 4. Right? You couldn't take the square root of all of it, so we broke it up so that we could take the square root of at least part of it. And the square root of 4 is 2, and we're left with the square root of 15 there. We tend to like to leave things as exact answers. Okay? Well, one more step. Okay? Notice I've got a 4 here, a 6 here, and a 2 here. I claim I can factor my numerator. I can pull out a 2. And if I do that, I'm left with negative 3 plus or minus the square root of 15 over 4. Why did I do that? Because I could simplify that. So I get negative 3 plus or minus the square root of 15 over 2. I understand it's not necessarily the most satisfying answer, but it is an answer, and again, you can put this into your calculator and get a decimal approximation. So, again, I'm sure you've seen the quadratic formula before and factoring before, but I urge you to practice a ton of these. It will only help you. Thank you.